Now, for our session this morning, we will be having the probability of compound events. And we will be dealing with these three topics here. Probability of the union of mutually exclusive events, the probability of the union of inclusive events, and the probability of independent events. Don't worry, as we go on with the lesson, we will be defining each term there. Now, let's begin. Let's start with what is a compound event. A compound event consists of two or more simple events that are connected by the words and or. Probably you have noticed this in our previous discussion, mga problems na ako nga I gave regarding probability. I made use of the word or. Like example, getting a heart or an ace. You have noticed that, right? I have already introduced this compound event, but I have not told you that we are having compound events. Okay? Now, so take note of that. When I'm using the connectors and or, that's a compound event. And you have noticed that when I used the word or in our previous examples last week, I simply made use of the operation addition. So, or indicates addition. Okay? Well, the word and, the connector and, this means multiplication. So, that's the difference between the and the or. And means multiply, or means add. Okay? Now, let's start with two events are mutually exclusive if both events cannot occur at the same time. These events have no common elements. Like for example, I'm going to give you a deck of cards and I'm going to be getting an ace and a jack. Naabay ace nga jack? Or naabay jack nga ace? Section Ruby. Wala. So, walay common elements. Maunay gitawag na ko og mutually exclusive. Meaning, exclusive ra ang isa ka event sa iyang kaugalingon og another event be exclusive ra sad siya sa iyang kaugalingon. Wala sila nag-share og elements. Parehas ra gud nag mag-uyab-uyab mo, dapat exclusive. Dapat dili mag-sharing. Kung si classmate A nimo, uyab niya si classmate B, si classmate C, uyab pod niya, lahi pod na, dili pwede si classmate B. Kay mutually exclusive man ang tawag-an ng event. And this will be our formula. It's so simple. You add the probability of the first event plus the probability of the second event. Okay? So take note, when I say mutually exclusive, no sharing of elements. No common elements. Is that clear? Okay, let's have our first example on mutually exclusive. A deck of cards. You have there a problem about the deck of cards. What is the probability of drawing a queen or a king? Now, here's the question. Is this a mutually exclusive event? Yes, because a queen and a king are different events. They do not share anything. Okay? And take note of the word or. So, what is the probability of getting a queen? 4 over what? 52, right? What about the probability of getting a king? 4 over 52. Okay, since we are having the word or, we will be adding them. So what is 4 plus 4? You will be getting 8 over 52 for that. Reduce 8 over 52. How much do you get? 2 over 13. Simple as that. This is the answer. Now, sir, can I make another solution? Like I will be simply adding, there are 4 queens, there are 4 kings, I'll be getting 8 cards in all. I will be dividing that by the total number of cards, 52, and that will be reduced to 2 over 13. It's totally the same. Okay? Do you understand the first problem? Okay, let's proceed to the second problem. Still a deck of cards, but this time you are having a red face card and a number card more than 4. Is this mutually exclusive? Na ay nag-share na abay red face card nga number card nga more than 4? Wala. So, mutually exclusive siya. So, let's start with the red face cards. How many red face cards do we have? 8. Ako ning i-shortcut ha. There are 8 red face cards. Plus, how many number cards? Wait. Red face cards. Is it 8? 6. Okay. Let me delete that first. This is an 8. That is 6. Okay. This is 6. There are, take note, Jack, King, and Queen. Nya, red man gi-indicate. So, duha ka Jack, duha ka Queen, ug duha ka King. All in all, there are 6 red face cards. What about a number card more than 4? How did you get 24? What are those numbers more than 4? Okay, and there are 1, 2, 3, 4, 5, 6. Yeah, your classmate said, sir, there are 6 number cards nga more than 4. Nya, times 4 kay tag-upat-upat na. So yeah, that's totally right. So plus 24. Over how much? 52. So you will be getting 6 plus 24. You will have 30 divided by 52, or reduce this. How much is 30 over 52 when reduced? 30 over 52. How much? 15 over 26. Divide both numbers by 2 to simplify that. So the answer to this question is simply 15 over 26. Okay? Let's proceed. This time, let's have colored balls. A box contains 4 red balls. This is 4 red balls. 5 green balls. And 3 blue balls. Helen draws 1 ball at random. What is the probability that the ball is either green or red? So start tas sa green. How many green balls are there? 5. Plus, how many red balls are there? 4. All in all, how many balls are in the box? There are 12. So adding 5 and 4, you will be getting 9 over 12. Reducing 9 over 12, how much is this? 3 over 4. Divide both numbers by 3 to reduce your fraction. So the probability that it's either a red or a green ball is 3/4. Okay? Now, this time, let's have the word inclusive. 2 events are inclusive if both events can occur at the same time. Like, for example, ako, I have a friend. I have another classmate. Iyahang friend pud nako. Mo na gitawag na kong inclusive. Meaning, we share the same friend. So, kanang mag-boyfriend mo or mag-uyab-uyab or girlfriend-boyfriend, dapat dili na siya inclusive. It should be mutually exclusive. Same thing with married life. Married life, dapat inclusive na sayad. You cannot share partners with any other person, right? So, this is now our formula. The probability of the first event, i-plus na nimo sa probability sa second event, minusan sa probability sa ilahang common. So, meaning, if ever I have 10 friends, the second person has 8 friends, niya ang common friend namo is 5, I will be adding 10 plus 8 minus 5. So, ako ang friends 10, niya iyahang friends kay example 8. So, all in all, there are 18 friends tanan. So, akong i-add ang 10 plus 8, minusan ako sa 5 nga common friends namo, mauna na yung probability sa nga answer nato. Okay? So, it's very, very important na you should analyze whether it is exclusive or inclusive. Let's have this example. A die is rolled. What is the probability of getting an even number and a factor of 2? What are even numbers from the dice? 2, 4, and 6. Okay, that's good. Now, what are the factors of 2? 1 and 2. When I say factors of 2, what are numbers that can divide 2? 1 and 2, sir. That's totally right. Now, unsay common nga number aning 2, 4, 6 ug 1, 2? 2. Okay. How many even numbers do we have? 3. How many factors of 2 do we have? How many common numbers do we have? All over ang dice. How many outcomes ang dice? 6. Mauna na siya ato ang concept. Gi-add na ko ang even o ang factors of 2. Gimainusan na ko sa common. O what is 3 plus 2 minus 1? 4 over 6. Reducing this, that is 2 over 3. Okay? Now, let's have another example. This one. It's still rolling a die. But this time, we will have prime numbers and also an odd number. What are prime numbers from the dice? 2, 3, and 5. Correct. What are odd numbers from your dice? 1, 3, and 5. Unsa may common ana? 3 and 5. So let's do the counting. How many prime numbers do we have? 3. Odd numbers. 3. Common. 2. All over 6. So what is 3 plus 3 minus 2? 4 over 6. That is still 2/3. Okay? Let's have another problem. What if I'm gonna be getting a 3 or a factor of 6? A 3 and a factor of 6. Now, a number 3, of course, the number 3. A factor of 6. What are factors of 6? 6. Okay. 1. What else? Sige, go. 3. What else? 2. There you go. Unsa may common nila? 3 ang common. Okay, let's do the inclusive now nga formula. There is only one number 3 plus 4 minus 1. Because we only have one element there. All over 6. So, how much is this? Uy, ang natimingan na ni siya ha, nga 2/3 always ang answer ha, pero dili na 2/3 permi ang answer. Because you might think, hala, basta dice kay 2/3 ang answer. No, it's not. It's just a coincidence na we were able to get 2/3 here. Okay? is mutually inclusive clear? Is okay, good. Very good. Now this time, napadi isa, napay cards. Okay, we still have cards here. We have here a red card and a queen card. So how many red cards do we have? There are 26. Okay. What about the queens? How many queens do we have? 4. Now, here's my question. How many red queens are there? Okay, -2. All over how much? 52. There you go. What is 26 plus 4 minus 2? 28 over 52. Reducing that, how much is this? Divided 7 over 13. Divide both numbers by 4. Okay? Let's have another example about a deck of cards. A face card. How many face cards do we have? 12. How many black cards do we have? 26. How many black face cards do we have? 6. So 12 plus 26 minus 6 all over 52. Oh, what is 12 plus 26 minus 6? 32 over 52. Reduce that. How much is this? 8 over 13. That's correct. Okay? Now, let's proceed now to dependent. We will have dependent first para ma-determine nato unsa kanang independent events, no? So, when I say dependent events, when knowledge of whether an event that occurs affects the probability of a second event. This means, for example, there are colored balls in a box. There are 10 colored balls. Okay, example, there are 10 colored balls. I will be getting one colored ball in the box. The probability for the second event will change. Why? Because sa first box, katong 10 kabuok, ang probability of getting a ball is 1 over 10. Diba? So take note, in a box, there are 10 balls. And then, if I'm gonna have the probability of just getting any ball, one ball, it's 1 over 10. Now, what if I'm gonna be getting it? I will not return the ball. How many balls are left? So, what is the probability of getting one ball from the 9 balls? O, na-change iyang probability from 1 over 10 na himong 1 over 9. That is what you call dependent. One clue word that you can use here is this. Not returning. Not returning the ball or the object. Or no repetition is allowed. Maunay dependent events. Okay? When I say independent events, thus the first event does not affect the second event. Like example, I'm gonna go back to my 10 balls. I'm gonna get a ball. I'm gonna return the ball. I'm gonna get another ball. In my first ball, the probability is 1 over 10. I returned it. There are still 10 balls left in the box. Therefore, the probability of the second event does not change. It's still 1 over 10. So you get the idea now. So again, when I say dependent, wala gibalik ang object. When I say yes, what do you mean gaypunan? Kung punan yung isa ka ball, ang katong iyang gikuha, pila ka balls ang ipuno? Depende po na. Isara. Kuan man guni siyang dependent, this is without replacement. Meaning, wala kay ipuno kung na kay kuhaon. So, if you will be getting a ball there, you will add a ball. Ang ball nga imong nakuptan good, wala chance nga mapilian siya. You get my point? Because there are 11 balls na tanan in all. The ball that you're holding and the 10 balls on the box. So the probability there will change because you have 11 balls na all in all. So take note lang taan ha. When I say dependent, it's without replacement, without returning. When I say independent, this is with replacement, meaning I will be returning the object. Okay? So let's have the formula. It's so simple. Multiply their probabilities. The probability of the first event times the probability of the second event. Okay? Okay, I'm gonna give you situations sa independent. Kanang coins. Tossing coins. That's independent. Okay? Because when you toss a coin, the probability is really 1/2 all the time. It will not change. It will not change. The probability of getting a head or a tail, it's 1/2. I will toss another coin. It's still 1/2. It will not change. Okay? For the cards, I'm gonna get a card. I will return it. Independent. But if I will be getting a card, I will not return it. That's dependent. Or let's have an activity on that. Let's decide whether the two events are dependent or independent. Rolling a 5 on consecutive turns in a game. Like for example, I have a dice. That's 1 to 6. I want to roll a number 5 on consecutive turns in a game. Will I get the number 5 during the second turn? The next might... Yes, it's possible. The probability of getting a 5 is 1/6. All the time. The first turn, it's 1/6. The second turn, it's 1/6. The third, the fourth, the fifth, it's 1/6 all the time. So it will not change at all. Okay? This is independent or dependent? Independent. What about the second one? Drawing a ball or a card from a deck of cards, returning it, and drawing another card. This is independent from the word. I said the key word is returning. Okay? It will tell you nga independent na siya. What about this one? Drawing a card from a deck of cards and drawing a second card. It does not say returning it. So meaning, wala gibalik ang second card din ha. So nagkuha ko usa ka card, yan nagkuha sa second card. Is this independent or dependent? This is dependent. Okay? What about number 4? Shooting 2 free throws in a basketball game. Sa first free throw, what is the probability nga ma-shoot ang ball? Unsay mga outcomes ana ma-shoot dili ma-shoot. So pila probability nga ma-shoot ang ball? 1/2. Sa second free throw, pila probability nga ma-shoot ang ball? 1/2 also. So what is this? Independent or dependent? Independent. That's correct. Number 5, forming a 3-digit number where no number is repeated. No number is repeated. Dependent. Again, no repetition is a keyword also for dependent events. Okay, number 6, forming a 2-digit number where repetition is allowed. Independent. So, This is very important when solving probability problems. You need to know whether it's an independent event or dependent event. Okay? Now, let's continue with our first problem. A die and a coin are tossed. What is the probability of getting a 6 and a tail? Is this dependent or independent? Independent. So what is the probability of getting a 6? Okay, a 6, that's 1 over 6. What about a tail? 1/2. The word and is found here. I will multiply the two probabilities. So what is 1 over 6 times 1 over 2? Oh, that is now the probability of getting a 6 and a tail. Okay? Let's have our next example. A die and a coin are tossed. What is the probability of getting an even number? How many even numbers do we have? 3 over 6. What about a head? A head. 1 over 2. Multiply them. How much is this? Reducing 3 over 12. 1/4. Divided by 3, both numbers, to reduce that. Okay? Are the two problems clear? Okay. Magka-complex ni ang problem sa I'm not saying magkalisod, magka-complicated lang siya, magka-complex. Okay? From simple to complex, tadere. Let's have 2 dice are rolled. Find the probability that a number 1 is rolled on the first die. How many number 1s do we have? So 1 over 6. Next, a factor of 6. What are factors of 6? How many are there? Okay, 4 over 6. Oh, multiply them. How much is that? 4 over 36. Reducing that, you will get 1 over 9. And that is your probability of getting a number 1 sa first die and a number 6 sa second die. A factor of 6, I mean. Okay? Let's go to our next problem. 2 dice gihapon. But this time, I want to get an even number. How many even numbers do we have from your dice? 3 over 6. Multiply this by getting a 5. What's the probability of getting a 5? 1 over 6. So multiply them. That is... Reducing that, how much is this? 1 over 12. Okay? Next. It's still 2 dice, but this time, a prime number sa first die. How many prime numbers are there in the die? 3 over 6. That's 2, 3, and 5. What about a multiple of 3? What are multiples of 3? 3 and 6. So when I say multiples of 5, 5, 10, 15, 20, 25. When I say multiples of 3, 3, 6, 9. But there's no 9 in the die, so we will have 3 and 6 only. That will give us 2 over 6. Multiplying that, how much is this? That's 6 over 36. Reducing 6 and 36, that will be 1 over 6. Okay? Now, let's proceed to colored balls. Okay? A jar contains 4 white balls and 1 black ball. A ball is drawn from the jar and returned before the next draw. What is the probability of drawing 3 white balls? So meaning, white ball, white ball, white ball. What is the probability of getting a white ball? 4. There are 4 white balls all over 5 balls all in the jar. White ball. Sir, 4 over 5, sir. White ball. Sir, 4 over 5, sir. Multiply all of them. How much is that? There you have it. You cannot reduce that. That's your final answer. 64 over 125. Is our problem clear? Clear Nisha section, Ruby? Okay, let's continue. Still, colored objects. So we have 3 red marbles, 3 blue marbles. A marble is drawn, then returned, then getting another marble. What is the probability of getting 4 blue marbles? So we have a blue, a blue, a blue, and a blue. What is the probability of getting a blue marble? 3 over 6. Blue marble, 3 over 6. 3 over 6. 3 over 6. Multiply all of them. How much is that? Sorry, this is 6. This is 81 over... What is... Yes. Again, how much? Reducing 81 and 1296, how much is this? It's not 1 over 8, it's 1 over 16. Correct. It's 1 over 16. Okay, 1/2 times 1/2 times 1/2 times 1/2 man na. Okay? Now, this time, what if it's not stated? Both are blue or both are green. I will be getting just a red marble and a blue marble. And it is not stated nga ang blue marble ang first marble, ang second marble ang red marble. It's just stated there, I want to get a red marble and a blue marble. So possible man na nga ang mag-una red, musunod si blue. Pwede man po sir nga ang muuna sir blue, sunod si red. So there are 2 possibilities here, 2 ways or 2 cases. Okay? So let's start with the red marble. What is the probability of getting a red marble? 3 over 10. There are 3 red marbles and there are 3 plus 4 plus 3, 10 balls in all. So this is also 3 over 10. What about the blue marble? 3 blue marble, 3 over 10 gihapon. 3 over 10. So how much is this? This is 9 over 100. And it's also 9 over 100. Now, unsa may buhato nako aning duha? You add them. Do not multiply. Kaya nga naman, or naman ni siya. Pwede man ko red, next is blue, or pwede man blue, next is red. So I'm gonna be adding 9 over 100 and 9 over 100. How much is that? Pero let's add them first. 9 plus 9. 9 over 100 plus 9 over 100. That's 18 over 100. Reduce that. That is 9. Okay. Now, natay shortcut, ani. Instead of showing the 2, you only need to show 1. But this time, multiply the result by 2 all the time. Okay? If they have different colors and it is not indicated unsa ang first ug ang second marble, multiply them all the time. So you have 2 times 9 over 100, mo nang ma-reduce ni nako, mahimo ning 1, mahimo ng 50, ang answer, 9 over 50. It's totally the same as this. Okay? Do you get the idea aning red and blue marble? Different colors. Is this clear, by the way, Section Ruby? Okay, let's have more on this. This time, I want to get a green marble and a blue marble. What is the probability of getting a green marble? Green marble. 4 over 10. What about a blue marble? 3 over 10. O multiply the 2. How much is this? This is 12 over 100. Nya, i-times na natog 2, kay pwede man blue, then green pod. You get the point here nga nung na-multiply kog 2? Okay, let's simplify everything. This is 24 over 100. Reduce 24 over 100. 6 over 25. There you have it. That is the probability now for this problem. Okay? Let's have another one. Still on colored marbles. But this time, I want to get the same color. What's your idea on how to go about this problem? When you say same color, can you give me a possible outcome? A red and a red, pwede. Or, pwede man sad siya a green and a green. Or, pwede po siya a blue and a blue. So there are 3 cases here. Pwede red, red, pwede green, green, pwede blue, blue. Let's start with a red and a red. What is the probability of getting a red ball? 3 over 10. I-times na kog 3 over 10. What about a green ball? 4 over 10. I-times na kog 4 over 10. What about the blue ball? 3 over 10 as well. Times 3 over. Now, what is 3 over 10 times 3 over 10? Okay. What about 4 over 10 times 4 over 10? Do not reduce, do not reduce. 16 over 100. What about 3 over 10 times 3 over 10? 9 over 100. Unsay buhaton na ko aning tulo i-plus. So, how much is that? 9 plus 16 plus 9. 34? Were you able to get 34, all of you? Divide or reduce that. How much is this? There you have it. 17 over 50 ang probability of getting a marble of the same color. Is this problem clear? Okay. Let's have another problem. This time, exactly 1 blue marble. So meaning, who can give me one possibility nga 1 blue marble? Okay, red and blue. What else? Is there any other possibility nga na i-blue din ha? Blue and green. So duha ka bukan possibilities. Pwede blue-red, pwede blue-green. So what is the probability of getting a blue marble? What about a red marble? Oh, what is 3 over 10 times 3 over 10? Times 2. Okay? Kay different colors man na. Ayaw i-simplify ha. This is 18 over 100. Okay? For our first case. Second case ta. Blue ball. What's the probability? 3 over 10. The green ball. Multiply them. Oh, double it. Different colors again. So you'll get 24 over 100. I-plus dayon na ninyo kay Ormanisia. Oh, what is 18 plus 24? 42 over 100. Oh, what is 42 over 100 when reduced? 21 over 50. And that's your answer there. Okay? Section Ruby, so far, is this clear? Anyway, I am recording this. I will be uploading this after this class. Okay? Ako ning gi-record karon. Next, last problem for this morning. What is the probability of getting at least one blue marble? When you say at least one blue marble, what do you mean by that? Pwede, one or more blue marbles. So meaning, pwede di ay ni blue o red. Pwede pod siyang blue o green. Right? Pwede pod blue and blue. Correct. Okay? Now, what is the probability of getting a blue marble? O butangan ta nag 3 over 10 tanan. 3 over 10, 3 over 10. What about a red marble? A green marble. Okay, multiply. How much is this? Unya times 2. You have 18 over 100 here. This one. Times 2. You have 24 over 100. This is... Do not multiply it by 2. Nga naman, same color naman na siya. Okay? Dili man na siya pwede magkabali-bali. Bisig, unsa pa ng bali-bali yun. Same naman gyapon na siya nga kuan. Okay? So we have plus 9 over 100. Okay, let's add everything. 18, 24, and 9. Can you reduce this? No, you cannot. Okay, that's your final answer.